Hello everyone, and welcome to the UT Austin Portugal workshop. The theme is Better Prepared, Strengthening Societies to International Scientific Collaboration. I'm Sheila Habib, and I'm International Relations Officer at the UT Austin Portugal Program, and I'll be moderating this session. Just before we get started, I'm just going to give the word to André Mota, a student from the school José Carlos Ferreira, who's just going to speak a little bit about the theme. Thank you.
Good afternoon. I came here to speak about a competition that I participated. This competition was EU SDC, where Ciência Viva and Portugal Space participated. This competition consisted of 3 teams, each team with students from many countries of Europe. The competition was each team was tasked with making a moon base for Jupiter's moon called Europa, and the team that made the best plan to go there would win. My job in my team was to take care of one of the departments that was the departments of operations. That department was assigned with the tasks that would be executed in order to maintain the moon base operational. For example, we had to take care of the energy production, the maintenance of air, the production of water, and the food. That were just some of the tasks. And for me, this project was very important, especially when it came to controlling my emotions when confronted with the overwhelming task that was this project. And I also realized that my English had to be worked in a greater level, because when we are tasked to talk with people from other countries, we see that our abilities are not what we think they are. And this project is very related to what we are going to talk here today, because it's international collaboration. This project consisted of basically making students, young adults basically, collaborate with people from other countries and work with science together. That's it.
Thank you, André. Does anyone have a question for André? No? Okay. So before I present to you our speakers, I'll just like to show you a video about the UT Austin Portugal program so you can see what I've been up to in the past year. Next.
When we said our farewells to 2019 and embraced 2020, we felt inspired, confident, motivated. The bar has been set high. The new year looks promising. But then the pandemic hit the world, redefining our way of doing things, connecting, engaging. At UT Austin Portugal, we work to thrive and give back our community of researchers, students, entrepreneurs, the confidence we had earned from them. Our 2020 activity report shows the importance the program places on sharing its progress, the accomplishments to be jointly celebrated, and the lessons it carries over into the future to further improve and excel. So what was our journey like in 2020? We launched 19 projects, forming new clusters of knowledge around strategic application domains. Our portfolio includes now 11 new strategic research projects, bringing together businesses and research organizations to deliver marketable science-based innovation. Plus, 8 new exploratory research projects navigating uncharted but highly promising fields of knowledge. We kept on tracking Phase 2 exploratory research projects on their way to full completion. we embarked on a digital journey to organize our annual conference, reaching far distant audiences, and set up for online masterclasses in state-of-the-art topics in the areas of the program. We carried on ensuring a steady stream of news pieces, digital content, and data to build up the program's brand and convey its impact. We remain committed to fine-tuning our monitoring and evaluation system, attesting to the program's learning and improvement culture. Our main 2020 takeaway? Hardships are only a shortcut to game-changing opportunities. The UT Austin Portugal Program is a science and technology partnership between the Portuguese Foundation for Science and Technology and the University of Texas at Austin, with the highest support of the Portuguese Ministry for Science, Technology and Higher Education and the Council of Rectors of the Portuguese Universities. Don't miss our new annual report. Find out how we lived up to our motto: create knowledge, foster change.
So now that you have learned a little bit about our program, let me introduce our National Co-Director, Rui Oliveira. He's also the Director of the Minho Advanced Computer Center and the member of the board at Tinesc Tech. Welcome, Professor.
Hello, everyone, and good afternoon. I would like to welcome you all once again to our UT Austin Portugal session at Ciência. This is Ciência 2021, even less physical than last year, but hopefully with a growing community everywhere and through these digital means of today. So we have just seen the digest of our activities last year, and I think it's pretty clear how the program has been keeping its commitment on a long-standing steering of science towards social and economic relevance, and even more so in terms of this exceptional good community that is growing with knowing each other, not only between Portugal and UT, but also everywhere. So the program has been having really interesting spillovers that are somehow supported by the excellence of the research that we all have been doing in the context of the UT Austin Portugal program. So with this workshop today, our goal is to delve the participants in this requirement, this growing requirement of looking for cooperation everywhere, looking for not only the problems that really impact society and economy, and work together to bring to the solution the contribution of everyone at all latitudes, of all experience areas, topics, and only this way we can actually make a difference and work for the social good. So, as you know, the program has been supporting several research projects, 11 strategic projects, so projects that are actually running for 2 years, and with a commitment, with a goal of really leaving, spilling over results to society, and then 8 exploratory projects where the ones we call high risk, high gain. Okay, so these are 1-year projects, so small ones, much more focus on science, on the, and not so much on the technology transfer. So from these projects, we will have the presentation of 4 of them, 2 exploratory projects and 2 strategic projects. And I hope you not only enjoy, but really share the excitement of having all of this running and keep contributing, keep applying for the activities of the program, and share the contributions that we all want to leave to the country and elsewhere. Okay, so thank you very much once again, and make the best of it. Thank you.
Thank you, Professor Rui. Now, I'd like to present João Paulo, a researcher at Inesctec, an assistant professor at the University of Minho. João is the coordinator of the project PASTOR. He'll tell us more about it today, but the PASTOR project aims at advancing the state-of-art storage solutions of high computing services through artificial intelligence. Thank you, João, for accepting our invitation.
Good afternoon, everyone. First of all, thank you for the invitation. I'm very glad, I'm very happy to be here today. And let's see if this is working. Oh, okay, yes. Okay, so what I'm going to talk about, to discuss with you today, is how can we improve supercomputers to be faster, to be more efficient, and to be able to support several applications at the same time and a huge amount of digital information. But before going into that, we have a question to answer. What is a supercomputer? And I'm going to give 2 perspectives. The first one is the user perspective. And a supercomputer for a user can be seen more or less as a regular computer, or used as a regular computer. But the nice thing is that it has a massive amount of computational and storage capabilities. So it can do a lot of calculations and handle a lot of data, digital information, but users can use it as a regular computer. And why is this important? Well, supercomputers have been used for different areas, such as physics, chemistry, or biology, again, to run very complex simulations that will take a lot of time in a regular computer. And this is the perspective from users. But then we have the perspective from system administrators, the people responsible for managing this supercomputer. And it's completely different, because now a supercomputer is not one computer, but a set of a lot of servers interconnected. And it's something like this. So there are hundreds to thousands of servers. These servers have different jobs to do. Some of them run applications and are called compute nodes. Other servers are responsible for storing data, so the storage servers. And the system administrator needs to be able to what? To check if everything is running smoothly, if the hardware and the software of the supercomputer is running okay. Needs to ensure that the applications running at the supercomputer are efficient, that this is reliable, and that it provides a secure environment for users. And having said this, this is the traditional vision of HPC, but now we have a new era of applications emerging, which are highly popular, and most of you should probably know this. So the applications are data analytics, artificial intelligence, and these applications are very nice because they can provide new predictions and new ways to support decision for key areas such as healthcare, finance. For instance, in healthcare, it can help with the present COVID situation we are living. And again, these applications require lots of computational power also to provide accurate and fast results. And this is where we can try to merge AI and supercomputing and HPC, right? Because we have all this computational power, we have the applications demanding it. So this is a great combination. But there is a problem. And the problem is that these applications, these AI applications, require a lot of data. The more data these applications have access to, the better the results. But each application of this can handle a lot of information. And what is the problem here? The problem here is a supercomputer has several compute nodes where the AI applications are going to run, and then has some storage servers. And all these applications will try to access and store data at the storage nodes, at the storage subsystem, let's call it this way. And the problem is that these applications are competing for the access to data. And this competition typically generates unstable performance. Some applications behave better than others or perform better than others. And in some cases, and this happens more frequently than we would like, the supercomputer can even become unavailable when lots of applications are competing for data. And so there is the need for a solution for this. And this is where the PASTOR project comes in. I'm going to provide a very, very high-level detail of the project, but I'm more than happy to discuss this after the presentation, and even if you want to contact me through email, I'll be happy to answer any questions. But the idea here is very simple. So what we want to have is some way of seeing the whole supercomputer, seeing all these compute nodes and applications running there, and understanding how they are behaving and accessing the storage, the place where data is stored. And this is done by a control plane, which acts on God mode and knows everything that is happening at the supercomputer. And then, if we notice that some applications are stressing the storage component, then we need to act and do something about this to, again, avoid overloading this component. And this is done by a software component called data plane, which resides near the applications. This project is a collaboration. It's an exploratory project, a collaboration between INESCTEC, TAC, MAC, and Wood College. And you have also here in the slides the website if you want to learn more about the project. And what do we expect to achieve with this project? Well, in terms of science, these are very hard challenges, which is very nice for science because we are able to work on our challenges. This allows us to have new collaborations, for instance, even with partners that are not directly involved in the project, for instance, the AIST Center in Japan. Then for HPC centers and the industry, if we are able to solve this problem of data storage for AI applications, then this means that the supercomputers will be able to support more applications, these applications will run faster, and there will be no downtimes, so this will facilitate the life for users and system administrators and will maximize the power of supercomputers and this new generation of exascale supercomputers that is coming now. And in terms of society, again, if we are able to run applications and studies faster at the supercomputer, this is better to advance science and to, again, advance key areas such as healthcare and natural sciences. And the problem with, to be able to achieve all these goals, we cannot do this alone, nor even if we work together as partners of the consortium. So we need to be able to collaborate with other researchers. And this is where the UT Austin Portugal Program comes in. The program has a very good network of collaborators, and this network of collaborators works on complementary areas, which is very nice. And so this is nice for what? For coming up with new ideas for projects and proposals and research. Also to validate the ideas we have on ongoing projects. And again, the program can also help on training activities and on dissemination and maximizing the impact of the project. And to conclude, this first sentence is not mine, but it's something that now is widely publicized. Data is more and more a very, very valuable resource. But in order for data to have value, it needs to be analyzed and meaningful information needs to be extracted from it. AI and HPC can be a good way of doing it, but we cannot only advance on the computational power of HPC. We need to look at how data is stored and retrieved. This is the main goal of the PASTOR exploratory project. And this is just an exploratory project, which is 1 year. So this doesn't mean we'll come up with a final solution. So this will lead to a lot of new projects and collaborations in order to address this relevant challenge. Thank you.
Thank you, João, for explaining to us a bit more about the PASTOR project. Does anyone have a question for João? No? Okay, I do have one. So the PASTOR is an exploratory research project. So from what I understand, we're still far from having a solution for market uptake. So is this true? What will it take to move from an open source prototype to deployable solution?
Is this, it is on. Okay, I believe you can hear me with a mask. Yes, again, this is an exploratory project, so many of these things we are doing are research. We work on systems research, which is nice because we can do prototypes, we can have open source prototypes. I expect at the end of the project to have some prototypes that can already be deployed, for instance, in Mac and TAC, which is also a partner. So I think it's to have a fully complete solution and to solve all the problems. We still have lots of challenges and nice challenges to address. But in terms of having a solution deployed in these supercomputers that helps with this problem, I think we are not that far away.
Okay, thank you. Thank you. I have one more question, if that's fine. So could you explain to us how well aligned is PASTOR with the Advanced Computing Portugal 2030 strategy, the MIM Advanced Computing Center, and the European High Performance Computing joint undertaking at an European level? How will PASTOR contribute to these strategies and initiatives that give Portugal a competitive edge in the international setting?
Okay.
Hard one.
No, those are a lot of points. But let me try to answer to all of them. Again, the goal of the project is to improve supercomputers and, again, to be able to leverage all these new supercomputers that are coming, that are arising. And so at European level, I think this is important. Again, a lot of supercomputers have emerged recently in different European countries. For Mac, I believe this is also very nice because it's a privileged partner, since it's a partner of the project. So I believe that, again, when we have a more stable prototype of ideas, we can test this on Mac infrastructure, and all the know-how will be in-house, so that it will be easier for Mac to leverage these results. And for the Portuguese strategy, again, I think this is important to raise visibility in Portugal that we are doing things in supercomputing and we are doing things with supercomputers. But besides the research and the impact I discussed during the presentation, I think that another important thing that is aligned also with this strategy is that, for instance, the PASTOR project in ESC, our team has several students working on this. So PhD students, master students, even undergraduate students. So we are building knowledge and training people in these areas, which I believe is also very important.
Thank you. I really like how you put it, that you're building knowledge. So thank you, João. Up next is Joana Dias. She's an associate professor at the Faculty of Economics at the University of Coimbra and also researcher at INESC Coimbra. She's a principal investigator of the AT at PT project in the area of medical physics, and she will talk about an emerging cancer therapy, proton therapy. If you don't know what proton therapy is, the University of Texas MD Anderson Cancer Center defines it as a 196-ton cancer-killing machine that can target a patient's tumor with a sub-millimeter precision while sparing nearby healthy tissues and minimizing side effects. But Joana will explain it in more detail, so welcome, Joana, and thank you.
Thank you so much for the opportunity to be here. So I am the principal investigator of an exploratory project called Automatic Treatment Planning for Proton Therapy. We are doing this project with a team from MD Anderson Cancer Center. Professor Mohan is the principal investigator from MD Anderson Cancer Center, and we also have other team members, both in Portugal, both in Texas, and we are all also involving students. In the Portuguese side, we have a master's student working with us, and in the Texas side, we have a PhD student working with us. So what is the core challenge of this project? What is it that we are doing? Basically, our main objective is to be able to develop automated tools to improve the quality of radiotherapy treatments, and we are focusing our attention on photon therapy. It's a new way, a new modality for radiotherapy treatments. Basically, what we want to do is to be able, in a totally automated way, to create personalized treatment plans that are really tailored for each individual patient. Our aim is to be able to develop these tools so that they are scalable, meaning that we are able to apply them to a wide range, a wide number of patients. They must be reliable. We have to make sure that these tools provide really high-quality treatment plans. They have to be fast. We don't want to spend a lot of time calculating these treatment plans. They have to be calculated in a way that they are compatible with clinical practice. And we want, basically, to release the human planner of a heavy workload that human planners nowadays have planning this kind of treatments. This is really an interdisciplinary project, and in our team we have many researchers coming from many different academic backgrounds. We have people from medical physics, computer science, operations research, and also medical oncology. And all of these disciplines are necessary to tackle the challenge that we are addressing. And why is this really a challenge? Nowadays, radiotherapy treatments are planned in a trial and error procedure. The human planner is assisted by a software that is called treatment planning system, and the human planner has to input to this system a set of parameters. He or she sees the results. If they are satisfied with the result, they stop. If not, they have to set up a new set of parameters, they have to try again, and these go on and on and on until they are satisfied with the result. For highly complex treatments, this can take hours or even days. Many decisions have to be made to configure all the treatment plan. Proton therapy is highly adequate for treating cancer, as I will try to show you in a bit. However, the number of degrees of freedom that we have to configure the treatment is higher, and as it is a highly precise treatment, we have to really make sure that we are hitting the target and nothing else. So this means that uncertainties that are unavoidable have to be taken into account during treatment planning, and this also adds complexity to this to all the process of treatment plan. So what we are aiming is to develop robust mathematical models, robust optimization algorithms that adequately deal with these uncertainties and can improve treatment quality, and can release, as I was saying, can release the human planner for this huge workload so that the human planner can concentrate on other steps, very important steps of all the complex workflow of treatment delivery. I want to show you just an example of a proton therapy treatment. So we have the patient that is laying on a couch, and we have to decide what are the directions that we are going to use for the proton beam. And we also have to decide how this beam is going to be modulated so that we really hit the volume that we want to treat and almost nothing else. It is not possible not to hit anything else, but we want to be as precise as possible, and we want to make sure that we are treating the volumes that really need to be treated. Why are we tackling this challenge now? Proton therapy is already in place in some settings. In Portugal, we don't have yet a proton treatment facility, but there is already a decision of installing one here. Nowadays, we also can take advantage of many developments that we have seen in the last years, both in computer science and in operations research, that make it possible now to use complex mathematical modeling, high intensive optimization algorithms, and we can now make sure that these algorithms can be executed in clinical compatible times. And we all know that we are expecting an increased number of cancer patients, and the truth is that even in Europe, we are not yet treating all the patients that should receive radiotherapy treatments. So this is really a perfect timing to do this kind of research. What can be expected of this project? Of course, that what we want is to develop tools and improve treatment that can increase the cure rate, they can decrease the number of secondary effects of these treatments, and this project is totally aligned with the 2030 vision of the European Society for Radiotherapy and Oncology that basically states that we should be centered on the patient, because considering really individualized, personalized treatments will not only have an effect on the patient, him or herself, but also on the society as a whole. And we are also addressing at least 2 of the United Nations 2030 Sustainable Development Goals. Has the UT Austin Portugal program been important for this research? I would say that we would not be doing this kind of research without this program. Clinical practice, clinical experience is crucial for the work that we are doing. We have to understand if what we are doing is really important in terms of clinical practice. And in Portugal, as I told you, we don't have yet a proton therapy facility. So being able to collaborate with one of the best cancer treatment institutes in the world, with a long experience in this kind of treatments, is an added value. For us, it's really a must. It has given us the opportunity to work with leading experts in the field. Professor Mohan is really one of the first researchers working in proton therapy from many, many years ago, where it was not yet foreseen that proton therapy would really be something that we would be doing in practice. So I would say that this program really opened the door for this fruitful collaboration. Of course, that this project has unavoidably been impacted by the COVID situation. So when we first did our proposal, we were expecting to be able to meet, to work together. It would be very good for the Portuguese team if we could go to the MD Anderson Cancer Center to visit the facility for ourselves. This, of course, was not possible. Even so, we have been working in a collaborative way remotely, and I think that we are all very, very pleased with the work that we are doing. Thank you so much for your attention. You have here my contact. If you want any other further information, more details, please feel free to contact me. Thank you so much.
Thank you, Joana, for your elucidating presentation. Would anyone like to ask Joana a question? I do. So we have seen that advanced computing can be an ally of proton therapy. It can help reduce many uncertainties that will refrain clinical practice from taking full advantage of this treatment, which uses the beams of protons to deliver energy directly to the tumor with minimal damage to the surrounding tissues. So being an interdisciplinary project, is there anyone who works at a higher level to effectively integrate different perspectives, angles, know-how?
Okay. Actually, the two areas are, we can take a lot of advantage of advances in HPC. We are not at that level yet. I would say that the biggest advantage that we can consider is really computational time and the ability of work with large data. And there is another step that we are not yet considering in this project, because in this project we are really considering mathematical optimization models and algorithms. But in the future, what we see in our vision of the future is that all these methods will also be combined with artificial intelligence methods, because I think it's a very good marriage. So in that way, also HPC can be a very good ally. Yes.
Thank you. Vash, I think you want to say something?
Exactly. Is this what? Okay. So the next question is mine, huh? What a surprise, huh? At some point, I was actually very interested in this subject since, I mean, I work in a space team, but then we work with a specific payload called a radiation monitor. So at some point, we're exploring the possibilities of turning our technology into being able to detect neutrons. And this came to the subject of secondary radiation from neutrons. I didn't see you approach this, which is of course completely fine, but I would like to get your comments, such as having this opportunity to be around you. It sounded really interesting at the time, and as we're here together, I would like to have a comment on this. Thank you.
I'm probably not the best person to answer this question, because I'm not from medical physics. I'm from the computer science and operations research field. But actually, one of the things that we have to account for when we are trying to automate the treatment planning procedure is side effects. And side effects have a lot to do with the secondary effects of the proton radiation. And there are a lot of people investigating in using other charged particles to treat cancer. But I'm really not an expert on that field, sorry. Sorry.
Thank you, Joana, and thank you, Vasco. So up next is Vasco Granadeiro. He's the head of aerospace at FASEC. He's a project coordinator of the Magal Constellation project. It's a strategic research project in the area of space and Earth interactions and has the potential to aid us in climate change monitoring. So thank you, Vasco, for accepting our invitation.
Finally, without a mask. So thank you very much. Again, my name is Vasco Granadeiro. I'm head of the aerospace team at FASEC, and it's an honor to be here. This is just a small index of what I'm talking about. So I'm going to talk about the Magal project. And basically, although there's a lot of text here, I mean, the major opportunity in this project is basically surfing the wave of new space. So for those who are not aware, space is now under a huge transformation, going from large, single, high powerful and high quality satellites to small, highly numbered and lower quality but then compensated in number satellites in providing the same type of services. Okay, don't be confused in thinking that smaller satellites can provide the same type of services as the one here presented in this image, which is Jason. I mean, we're also working with altimetry. We're working with smaller satellites. We won't be able to compete with this size of technology, although we're going to be using more recent technology, of course. But the aim is actually to complement the value proposition from these more large and powerful satellites with smaller ones and offering other types of more competent objectives, such as the frequency and the quantity of data. Again, there's a positive externality in this project, which is to foster the ecosystem around space in Portugal. And of course, as you know, there is a geographical and social opportunity in developing a space ecosystem, because we also can provide great launch facilities. But then this is, of course, not provided with our project. It's just a very positive externality. Going into more detail, the value proposition for this project is, of course, working with a radar altimeter. This is one of the aims as us capitalizing all the work that we have been doing with ESA. So Portugal has been part of ESA for more than 20 years. In all these projects, and this, of course, specifically, is aiming to get the technology that they've been working so hard to develop along the years and transform it to this new concept of space. This is the case of the radar altimeter. It's the one. It's already in a very high TRL, something around 6. One day we'll have the opportunity to go in an ESA mission and become TRL 9. And in parallel, we want to develop this lower cost and lower size technology for small sats. Also, there is, the project is going to involve data processing, which I'll talk a bit further ahead. And as I mentioned before, the concept is changing. So we're moving to standalone great satellites, so in size, to smaller ones, getting more frequency, but of course complementing the offer coming from the satellites on the previous space concept. The data center, I mean, all the data around these satellites are not going to be just devoted to data coming from altimetry. It's going to aggregate data from other sources. And of course, it's also a cost advantage in working in a low-cost system compared to traditional large satellites. As studies for baseline, so this will be competent, and these are the four areas that we aim for the Magal constellation to offer output in terms of the sea surface topography, in terms of eddy currents detection and tracking, marine debris monitoring, and coastal inland water levels. And there are other cases that we are considering, but it may not happen that are considered, which is internal waves, species migration, and marine meter monitoring. Again, as I said before, this will not involve only censoring, so gathering data, but will involve also the visualization of data, namely by developing its own algorithms using artificial intelligence and the visualization system. And this, of course, as I told before, is not only going to be processed just only with data coming from the Magal constellation, but also with other data sources in terms of getting like co-processed and a larger value proposition coming from the project. Of course, this will be made in a design level. It won't get to it will only be made in the prototype level. In terms of software, it won't be made into a larger platform. Hopefully, we'll get the opportunity in a project in the future. Going into more detail of what the Magal constellation is going to be, it's being thought, this is already progress in the project, involving 6 satellites between, I mean, this is nomenclature coming from these CubeSats, these small satellites that are modular, made by cubes. So this is the size of satellite. You can check it online. And the size has not been established because we're still considering the payloads to be involved. Overall production budget is around 3 million in terms of an estimate nowadays. As I told before, still payloads are being under selection. Of course, one that's already been decided, and this is going to a prototype level, is the radar altimeter. So we're going to move the prototype that we're developing from ESA into a lower size and cost, and develop a prototype for the project and make it fly on a drone just to test and validate the concept. The orbit for the constellation is around 500 to 600 kilometers. For those who are not aware of scale, this is really close to Earth, and we're considering a 90-minute period around the Earth. And actually, the revisiting time under optimization and spatial and time resolution is still under study during the project as it goes. The impact, these are the main areas that we're considering to gain from the output from the project, namely the large infrastructures in Earth regarding shipment transportation, insurance companies in terms of getting the size of the assets that are being insured by those companies, offshore infrastructures such as aquaculture, meteorological institutes in order to process and anticipate climate predictions. Governments, of course, in all these institutions, namely coastal surveillance and marine effects. oil and gas infrastructures, and of course, the scientific community. Just as a last slide, we want to thank the UT Austin in collaborating with us. Of course, they are an unavoidable element in the project due to their experience. They've been involved in more than one mission, such as the GRACE mission. They were involved in developing the systems architecture for the satellites. And of course, I mean, they are within a much larger space ecosystem that us here in Portugal. And this is, of course, a larger gain in having them on board and trying to work, although there is a geographical distance and COVID stopping us from visiting them, trying to work as a team, promoting, of course, as much as possible frequent meetings. Thank you very much. Any questions?
Thank you, Vasco. So since anyone doesn't have questions, I do. So the new space economy has been growing at a steady pace over the last years in Portugal, with several strategic public investments pushing for the creation of a true R&D and innovation ecosystem, mobilizing companies, startups, interface research institutions, collabs, and academia around space-related projects, as a way to understand the Earth better. Where does your project stand in this ecosystem, in this constellation of projects?
In small words, right in the middle. So, I mean, the objective of this is actually to promote that type of ecosystem that you just mentioned. So, as you know, we're not alone. I mean, this is a large consortium, actually very large, including UT Austin, as I just mentioned. So, the objective is mainly to foster this ecosystem around this. So we are aware that this is only going to go up to prototype level, but then this is of course not the end of this. But then this is, as I mentioned before, is a perfect example on capitalizing all these 20 years that Portugal has been working with ESA and putting this effort that has been mainly with ESA focusing on space exploration, so going into planets and orbits, much further away from Earth in order to, at some point, just to conquer space and to satisfy human curiosity and make this into a business. So this has to be profitable for the industry. There has to be a value proposition involved in all these 20 years of capitalizing in getting knowledge for this. So the objective of this is actually to spin off technology that's been used to satisfy human curiosity into creating real value for the economy on Earth.
Thank you. I have another question. In the past, Portugal has mastered the seas and gave new worlds to the world. Are micro and nano satellites Portugal's new caravels to explore Earth's future from space? Is Portugal building strong scientific and technical capabilities to be at the forefront of mega satellite constellation design and development?
Look, as you know, the space is now what the sea was when we were exploring the world. So basically, I mean, now it has some law for it, but basically it belongs to no one. So this is a huge possibility for Portugal just to occupy its share of space and develop and conquer the world with it. I mean, there is a very large bet on this sector made by both the government and also by the whole ecosystem in putting this into a real opportunity. So if this means that we're going to be world famous again, yes, of course.
Thank you. So up next, we have Sérgio Silva, the founder, Chief Executive Officer of Advantech, Advanced Environmental Technologies. He's connecting with us remotely, and he'll talk about a very exciting project, NanoCat Red, which has the potential to remove contaminants from water. Sérgio, the floor is yours. Welcome. Can you hear us? We can hear you. No, we still can't hear you.
You can hear or you can't?
Now we can. Thank you.
You can. Okay. So, hi to everyone. It's a great pleasure to be here. So, I will talk about water and about NanoCat Red project. So, my name is Sérgio Silva. I'm CEO of Advantech. NanoCat. Okay. So, first, I want to say some words about water. Water is one of the primary source of life, and in 2017, Health Organization published a document with guidelines for drinking water quality. And it contained recommendations for the risks of managing risks that compromise the safety of drinking water. So it's essential to preserve the quality of water, even with the development and in the industrial world, and it is a primary concern to preserve the quality of water. And the NanoCat Red project is all about this, is treat some of the pollutants of most common pollutants of water. So the safe drinking water, as all of us know, is required for several purposes, such as drinking, food preparation, and personal hygiene. So the World Health Organization guidelines focus in the different aspects of this safe drinking water, and this document separates the microbial aspects, most common of bacteria, virus, that can affect the quality of water. It also focuses in chemical aspects, and contrary to microbial contaminations, many of the chemical pollutions cause troubles, effects, problems in health after a medium long term. So many times it's not immediate problems, so it's very important to focus in these chemical aspects that not have an immediate effect on health. So another aspect is radiological aspects, and also acceptability aspects regarding, for example, taste, odors, and turbidity of water. So these guidelines about safe drinking water, safe water, present a list of more than 100 compounds that can be potentially hazardous. So, and the NanoCat Red project will focus on some of these compounds, namely oxygen-containing anionic compounds that are called oxyanions. In NanoCat Red project, we choose 3 of these oxyanion compounds: the nitrate, bromate, and perchlorate. I will explain later how do we choose these 3 compounds. So these 3 compounds are present in many countries, we will see later, and each of them have some problems, associated problems with the health, have induced some problems in health. The nitrates will affect the way of blood carries oxygen in our organism. The bromates are from some years, it is known that these bromates can have a carcinogenic effect on humans. The perchlorates also have caused problems in health, mainly in the thyroid, and most of them, the main source of these contaminants are from agriculture, from for example, for nitrates, and for bromates and perchlorates, mainly for industry sources. They are the main source of these pollutions. Actually, most nitrates and bromates have limits for discharge. Perchlorate not yet. And about the treatment. All the existing treatments, most of them are effective right now. But the main problem of the existing treatments is that most of them are separation processes, which means that what we are doing is separate these contaminants from the the clear water. And in one side, we have treated water with no contaminants, but after we have a stream with highly concentrated pollutants, and this stream should be disposal in somewhere. So we are not removing the contaminants. We are just only what we are doing is concentrate and separate contaminants and put these contaminants somewhere. What we propose under NanoCat project is not separate these contaminants, is transform these contaminants into non-contaminant compounds. So regarding these three contaminants, this is the occurrence in the world. As we can see, this is two main groups of countries. The first one is highly industrialized countries, Europe and United States, and also countries with the agriculture is highly intensive. Okay? So you can see that is a world problem that should be solved for these three components, and this is growing year after year. So it's the treatment performance. Like I said previously, the existing technology not transform these contaminants, only separate them and concentrate them. So we need to solve this problem, not separate these contaminants and concentrate them, but convert these compounds into non-pollutant compounds. And this is what the main purpose of NanoCat project. We use technology called catalytic hydrogenation to transform these components, these oxyanions, into non-contaminant products. So the main advantage, it can be operate at normal temperature and pressure. The hydrogen can be recycled to the system. And like I said previously, this is not generate secondary highly concentrated streams. Under NanoCat project, we will also develop and test several nanostructured materials to increase the treatment efficiency, the catalysts, nanocatalytic catalysts. And these catalysts will be tested in the pilot unit that we build and test to check if this new catalysts and this new technology is effective. And we test it with the real water and real pollutants in water. So the main added value of this project, as we can see, it's a new and efficient solution for purification and remediation of water with this kind of contaminants. And this will create a new regional industry, like this, a new technology with great impact in the treatment of water. This is a new technology with equivalent solutions are available in the market. And of course, NanoCat project will take advantage of this opportunity to develop these nanomaterials and this chemical transformation for environmental application. So this the NanoCat project also contribute in the not concern research and development, contribute for development of new nanomaterials, development of metalworking industry to the development of new equipment, and of course development of water and wastewater treatment company as we have now we will have a new technology to solve the problem with at least these three compounds. The NanoCat Red project is as we know, under the UT Austin program, and we take advantage of the strong experience of UT Austin with the oxyanions, removal from water, and this knowledge complemented with the knowledge of Portuguese Academy, I think, in my opinion, will have all the can make technology that can be applied. And Adventech is a company with strong connections to industry and food industry. So we can apply not only in scientific way, but we'll build equipment that we can apply in the real case and have a technology that can be available not only for Adventech, but for the companies that can solve these problems. This is the main aspects of the NanoCat Red project and the challenge and the advantage that we have with this project. Thank you for this opportunity to present NanoCat Red project.
Thank you, Sergio. And I'll have a few questions, if you don't mind. So in your presentation, you mentioned other technologies available to treat the oxyons compounds. How does your solution differ from your existing ones, and why did you decide to address these compounds specifically?
Yeah, the NanoCat technology is we transform these compounds, these pollutants, in other non-pollutant compounds. The existing technology are separating technology like membrane. What we are doing now, this technology are efficient, but what we are doing is separate the pollutants from the treated water. So we have a stream with highly polluted, and we have another side treated water. What we propose under the NanoCat Red project is transform these pollutants into non-pollutant compounds. So we don't have any concentrated stream. This is the main advantage. And the reason that we choose these three compounds is because they are frequently present in the waters. They are difficult to degrade for conventional methods. This is why we actually choose separation processes. So the advantage of the technology under the NanoCat Red project is degrade these compounds into non-pollutant compounds.
Okay, thank you. And do you envision any cost barriers to NanoCat Red's adoption by the market in Europe and beyond?
Excuse me?
Do you envision any cost barriers to NanoCat Red adoption by Europe and beyond?
No, actually, depending the material that we use in the nanoparticles, the cost of catalyst could be more or less, right? Depending the kind of metal you're using. But what we'll do is we test different kinds of metals and catalysts. We will choose ones that have a cost efficiency, the better cost efficiency. So I think the main challenge is not cost barriers, but it is the improvement or to build an equipment and to industrial level. and not
Okay.
the cost, but the technology itself at its real scale.
Okay, and I have just one more question. How does your project align with Europe's Green Deal?
Okay, this is an easy question. As you know, the Green Deal, what we want with Green Deal is making Europe climate neutral without place many barriers to development. So what we want is developing countries should continue to development in industry continuous development, but in neutral climate way. And Nanocat Red project, it's all about this. It's about water. We know that these kind of compounds are mainly generated by industry and intensive agriculture. So in one way, the industry should reduce these emissions. Agriculture should also reduce the emissions to water. But after this, there are some contaminants that we are not able to completely eliminate without stop the development. So we have to develop technologies that are able to treat these compounds. So it's all about this.
Okay, thank you very much, Sergio, for joining us. So before we go ahead, I have one more question to João Paulo and Vasco, if that's fine. So your projects are industry-driven research projects, and you have academia working side by side with you. How difficult is it to converge academia interests with industry ones? João Paulo.
Okay. Well, for this project, actually, it's not difficult because the industry in Pasteur is TAC and MAC, and although these advanced computing centers, they are providing a service, so they have a lot of similarity with the industry. Things cannot fail and need to be production ready. But they are also very strong in terms of research. They need to innovate to be able to attract more users and to advance the supercomputers. So in that sense, it's very easy to work with them because the bridge between industry and academia, they already know how to do it. And again, from our side, it is also a bit easier because, as I said in one of the previous answers, our line of research is very system-driven. So we already work with prototypes. It's not just theory. So it's not that difficult to do that.
Thank you. Vasco?
He took the words out of my mouth. So, I mean, the same on our side. I mean, if you want to draw a border, which is not a border at all, I mean, industry is more into, monetizing whatever solution, and academic is more interested in research. But basically, both challenges are equally challenging, and basically they do merge. So I guess it's just a way of driving the challenges in one way or the other, and it's actually a very profitable synergy in having these different types of interest on the table. Basically, we just have to, not drawing a border at all, and then just pushing us into respecting the other guy's area, which actually comes to success. If everything fails, I myself have 2 masters and a PhD, so I actually came from academia, and now I'm in industry, so I'll use myself as a bridge if anything fails, but then it hasn't and it won't.
Thank you. Joanna, if you don't mind, I also have one more question. So proton therapy is regarded as a very expensive modality in cancer treatment with high upfront costs. But in your presentation, you said that your project aims at treatment planning solutions that are scalable, reliable, fast, and cost-effective. So do you think that your project can be a stepping stone in democratizing access to proton therapy?
With our project, we are not going to be able to decrease the costs of installing proton treatment facilities. I think that we can, however, contribute to lowering the costs, because one of the main obstacles for treating more patients is really the time that it takes to plan the treatments. So if we have a solution that is totally automated, what we are aiming is that the professionals can treat more patients and they can focus on other very important parts of the treatment delivery process. So I think that our contribution related to cost has to do with the number of patients that we are able to treat, because we are going to be able to plan these treatments faster.
Thank you. So we're almost done our workshop, and just before I pass the word to our last speaker, I'd like to show you this video about our upcoming annual conference in October. I hope that sparked your curiosity to register for our conference. So now I just want to thank you all for staying with us throughout this workshop, and I'd like to pass the word to Professor José Manuel Mendonça. He's the director of the UT Austin Portugal Program and also the chairman of the board at Inesctec. Welcome, Professor, and thank you all.
Hello, good afternoon. Thank you very much. Thank you all for being with us in this session. The motto of Ciência 2021, science that builds tomorrow, that is our future and transforms the economy, is totally aligned with the motto of this session, the UT Austin Portugal session, strengthening societies through international scientific collaboration. In a session in the morning, on the mission and partnerships of Horizon Europe program, a most relevant item of discussion was why Portuguese companies and institutions bother to participate in European programs if they have the Portugal 2020, the FCT projects, now the PRR, the Redesigning program, and future Portugal PT 2030. Why do they bother? And the conclusion is that international partnerships have much more than financing, have much more than money. They have an access to an international standing, like our young speaker, the first speaker was telling. The international standing is difficult, it's challenging. And he expressed it very, very, very well that. So they offer access to world-class information, to world-class partners, to world-class ideas, and sharing with companies also information on markets and potential clients. So it's not just money, it's not just financing, it's much more than that. So why should Portuguese companies and research institutions bother to engage in UT Austin Portugal partnerships? Because it's even more difficult, it's even more challenging, it's far away. It takes many hours of flights to go to the US, to go to Texas, for all those reasons I just mentioned and some more. And I'll mention some of these reasons based on the presentation of the speakers to whom I want very much to thank the presentation. The first presentation was on supercomputing, high-performance computing. Portugal is engaging in HPC program in Europe, and now it has a supercomputer that's going soon to be installed in the Minho Advanced Computer Center, the Eucalion, and it's going to be a green, low-carbon footprint supercomputer. And this would not happen if there was not the Bob, the first supercomputer, which was offered by UT Austin, and also if Portuguese were not trained in the Texas Advanced Computer Center. So the supercomputer, the HPC networking, the Deucalion wouldn't be possible without the UT Austin Portugal program, full stop. Then the second presentation was on proton therapy, which is a project in partnership with MD Anderson Cancer Center. I visited with Rui and the minister a few years ago, and when I came to Portugal, I just asked a friend of mine, top researcher in cancer in Portugal, what do you think about MD Anderson? And they said, oh, this is world top. Were you there doing what? So in the same way, this partnership wouldn't have happened. Portugal wouldn't have access to this partnership, to this information, to train people on the research, to build this capacity that we need to prepare the country to a possible installation of a prototherapy cancer center without the Portugal UT Austin program. So, because of course we need to acquire advanced competencies before we run to this investment of 100 or 150 million euros. The third presentation was what we call on the new space, satellite constellations, an area of new opportunities which are opening to Portugal, engaging not just EFASEC, a leading company in Portugal that Vasco represents, but many Portuguese companies and also the recently created Portugal Space. This is a strategic project financed by UT Austin Portugal Program, but it's not just collaborating on space. It's very important because the impact on monitoring coastal lines, to monitor fuel content in the forest to prevent forest fires, climate data, etc., are all highly relevant to the country. And finally, the fourth presentation, also from a strategic project from the Austin Portugal program, addressed the most important problem of detecting contaminants that affect both health and the environment through nanotechnologies. So I could close with an hybrid of the Ciencia 2021 motto and this session motto, telling that the science that builds tomorrow and transforms the economy is also the science that strengthens the society. All in all, it's science with impact, which what this program pursues and is offering. Thank you very much.